Hello, construction materials and detail students. This is Detail Detectives. So as you know, when we had lecture before COVID-19, we would cover concepts briefly in lecture. And then we would walk around campus and see these concepts applied in real life. The point of this Detail Detective Challenge is these lectures that we were reviewing basically gave you clues, right? Gave you clues about how things were constructed. So material dimensions, that's a great clue. Looking for the presence of weep holes, looking at plant health in raised planters to see if they're draining properly. All of these are clues into how these elements were built, but also how they're functioning. So today we're going to be looking at a ramp. This is the ramp right outside of Dale Hall. And the first thing I want you to do is to determine the height of this brick wall right here. I feel like a weather person, right, with the map in the background. Anyway, so you're going to figure out the height of this wall by counting the brick. And I measured, and these are standard brick, so that means they're 2.5 inches tall. So groups of 3, as we learned in lecture, equals 8 inches, which is really handy to know because 8 inches is also the height of a concrete block or a CMU. So basically, if you see a retaining wall that you suspect is a brick veneer with concrete block behind it, then when you draw that, you just want to make sure there are 3 brick per block, provided that the brick are standard. Okay, but these are standard size, 2.5 inches, groups of 3, 8 inches. So go ahead and pause the video and figure out the height of this wall. Okay, the next thing we're gonna do is figure out the slope of this ramp, because we want to check to make sure it conforms to ADA guidelines. So again, if we're in the notion of counting brick, what I'm gonna do is I'm gonna run to the top of the ramp and then trace the brick down, and then you're gonna count the distance, right? So I'm gonna run up to the top of the ramp, trace it down, I'll be right back. All right, you have to count. So now you know the rise, right? Because you counted brick and you did basic math. The run, I measured earlier, that's 44 feet. And so I want you to use that calculation and come up with the slope of the ramp and let me know whether or not it's ADA accessible. So I want you to email me the slope and whether or not it conforms to ADA. So that's it for the ramp. Let's take a closer look at the brick wall. All right, so let's look at more detail of this brick wall. So we'll notice here that at the very bottom of the ramp, we see a light fixture. Right? And then let's just walk the length of the ramp looking for the next light fixture. I don't see any. All right, here it is. So there's one at the top of the ramp and one at the bottom of the ramp to illuminate the ramp at night. We see a handrail, and it looks like it conforms to ADA. But you should review the lecture slides to double check that. So things like the edge that curves back to the wall, the attachment that still allows for a hand to be placed without obstructing that grip, all of that conforms to ADA, and we can see periodically along the rail it's attached to the wall. So let's take a look at the width of the wall. So wall width would give us a lot of clues to how this wall was constructed, whether it's a cavity wall, whether it's a solid wall with 2 rows of brick, whether it has a concrete block and a brick veneer. So the width of this wall is a really good clue as to how it was constructed. So we see it's basically 1.5 bricks wide. And you know, this choice of cap isn't the greatest choice because look at all of the mortar joints that you have on this cap. Since it is a horizontal surface, water is likely to collect here and pool. water can eventually penetrate the mortar joints, causing them to break down. So this type of cap is not the best for longevity. But nevertheless, this is what we have. But we saw that when you had this kind of brick roll-lock cap, that one consideration was at the end. With core brick, if you didn't order solid brick, then you'd be able to see the brick holes, which is not aesthetically the best. So let's take a look at the end of the wall to see how they treated the cap. All right, this is really the best angle I could get. It seems like it's just like a concrete cap at the end. So the roll-lock comes down the wall and ends in this concrete cap, so there was no need to order any sort of solid brick. Yep. All right, and then this column here at the end ends in the concrete cap, and then the column sticks out about a brick and a half from the wall. And then let's take a look at this wall. So it's just a very tall wall, just directly adjacent to a sidewalk. It seems like the overall pattern is running bond with the brick roll-lock cap. Okay, looking at the bottom of the wall, we see an expansion joint, which we see that typically when two different materials abut. So as we know from lecture, an expansion joint goes all the way through, so these two materials do not touch. And typically these expansion joints are filled with something that would prevent water from penetrating. But also look, do you see the weep hole? So this looks like after the wall was constructed, they came in and drilled out the weep hole. And we see that also here along the wall. And then do we see it anywhere else? No. I don't see any more weep holes at the bottom. Is that one? No. That's just where the mortar has broken out. Huh, that's interesting. So again, I'm not seeing any weep holes along the bottom. Sorry, it's hard to carry the camera and walk. Let's see if there are any weep holes at the other end. That mirror. I'm not seeing any mechanical weep holes, metal ones that were installed with the wall, and so this is the only one I see. And so again, this was added after construction, I bet. They built the wall and then drilled that weep hole in. So in looking at the fact that there aren't that many weep holes in a wall this size, I bet this is not a cavity wall. So this must be a solid wall, right? Because if it were a cavity wall, we would expect to see more weep holes. And is that one? Yeah, that's one I missed. All right, so that is the ramp and the retaining wall. So again, what I want you to determine is whether or not this ramp is ADA accessible, and then I want you to draw a detail of this ramp, just a section of the ramp with the wall. So what you'll want to include, depending on where you draw the section line, is the slope of the ramp, have some sort of notation about the slope. You'll want to get the handrail in there. Again, depending on where you cut your section line, you'll have the lighting. If you don't include the light fixture, definitely account for the wiring that would be used for the light. And then we need to make a determination about how this wall was constructed. So we have this clue of the width. We have the clue of the limited weep holes on the other side. And so I am guessing this probably isn't a cavity wall. So what's inside here? I'd like to see what you think. Anyway, that was ramps for our detail detectives.